That's a hard discussion to follow, but we'll try our best. Uh, Pretty excited to welcome two extraordinary founders that started out with like massive visions and ambitions. And I've been fortunate to kind of be with them in this journey. They were able to tag me along as an investor in both the companies. And both of them have kind of built like unique primitives in the data stack, and that's kind of why we're kind of having this discussion about unpacking what's next in the data space. I'll start off by introducing Jordan. Jordan has been a data practitioner for a long time. He's one of the founding engineers of BigQuery and was one of the product leads at BigQuery as well. And after that, ended up leading product at Single Store, and then decided to build a company around DuckDB. It's called MotherDuck. And the company has a lot of momentum. It's a rocket ship. It's been accumulating fuel with every round of funding, and it's been exciting to see the growth. Ryan is being a data practitioner across multiple companies as well. He was at Cloudera before, and then was at Netflix. At Netflix, he created Iceberg, and spun out Iceberg to create a company around Iceberg called Tabular. And the company was recently acquired by Databricks for a massive $2 billion plus acquisition. Congratulations, Ryan.
Thanks.
Great to have both of you over here. But let's start by talking about like the two primitives itself. Ryan, let's talk about like what is Iceberg, what is Tabular, and if you could like spend a few minutes talking about the journey with Tabular.
Oh yeah, absolutely. When I started working at Netflix, I was working on the data platform. So we were the infrastructure team providing Spark and Hadoop and all of the things that we were just talking about in the last talk to practitioners and people actually trying to get value out of the data. And while we were doing a lot, it was just incredibly hard for people to get value. We noticed a lot of problems just in like needing to retrain people. So if you came to our platform and you ran a simple write query, you would often find that you corrupted a table or something silly like that. And it was just very, very hard to use. It was unreliable. And we had to literally reteach people how to work on our platform. And at the same time, there were other just really terrible holes where if you renamed a column or if you dropped something, you could again corrupt your data and have problems. And we looked at three different areas: that usability. We looked at basically the reliability. Why didn't we have primitives in our own database that actually worked reliably all the time? And then we also had, everlasting scale and performance challenges at Netflix scale. And we realized that what was going on was we had this system that was very simplistic from the old Hadoop days of managing data as a table. And it basically used a directory system and said, that's good enough. We'll call that a table. And it just was not sufficient for transactions or like things that you can reason about and have correctness. So we decided to fix that layer so that all of the different systems that needed to interact could safely share tables without actually going through one central database bottleneck. And what we realized later was that that's not actually how normal databases are architected. So we created this pattern for essentially storing everything in S3 or another object store, and then realized that itself was more powerful than what we were trying to do in the first place. We'd created this way to safely build data warehouses on top of S3, and to run Pig or Hive or Spark all at the same time with the same data store with almost no shared infrastructure. And so that turned out to be a lot more powerful, and is one of the reasons why the technology just took off, because that was what everyone wanted. They wanted to have the right tool for the job and not be constrained by, oh, I put my data into this data warehouse, now I have to make everything fit into that box in order to use that data. So that's why we started Tabular, to build a platform that you could plug any compute provider into and provide it as a service.
That's great. And we'll come back and talk about Iceberg, but Jordan, could you talk a bit about your journey with MotherDuck and what led to that journey?
Sure. So first of all, I didn't start out to start a company. I encountered this database called DuckDB, and it was created by a couple of researchers in the Netherlands. And I'm like, this can solve a bunch of problems that we're running into at SingleStore. So I just helped SingleStore kind of take their on-prem database, kind of move it to the cloud, and we just kind of butted our heads against a couple of like just technical problems on how we can scale it and how flexible we could be. And I'm like, somebody should take this DuckDB database and build a cloud service out of it. And I'm like, hey, I've built 2 cloud databases as a service. Maybe that should be me. And I thought I would just hack on it for a little while. So I asked a friend of mine who is a founder, Lloyd Tabb, the Looker founder, to introduce me to the DuckDB founders because I knew he knew them. And he said, yeah, but you should start a company. And I was like, well. And then he said, you should talk to my friend Tom, who invested in Looker, and he'll give you some feedback on the idea. And so I talked to the DuckDB guys in the morning. They were interested in partnering, and then I talked to Tom, who became our seed lead in the afternoon. He's like, yeah, it's a good idea. I want to fund it, and so I was like, kind of shocked. I didn't think that that's how starting companies worked. Actually, I met Apoorv like 3 days later, and he had sort of like had heard something's going on. It's amazing how quickly the word gets around, especially like some people are good at having their ear to the ground. Yeah, so that's how I met Apoorv, and then just sort of people came out of the woodwork interested in working on this project with me. Like some people I'd worked with before, some people who'd been customers before, and then some people who just really liked DuckDB. And all of a sudden, then we were off and running, and it's been a super exciting journey since then.
Yeah, super exciting is an understatement, but yes. I'm curious. Like I think a lot of founders, especially creators of open source projects, always ask this question that like, what should be the managed offering around this open source project? Is it even worth building a commercial product around this open source offering? And maybe that is the wrong question. Maybe it's like not on the open source offering. Maybe it's adjacent to it. So curious to kind of dig into that piece. Even before, Ryan, you left Netflix, Iceberg had adoption outside of Netflix. And that had adoption bottoms up from data practitioners, from data engineers. What market insight or product insight gave you conviction that you could create a managed offering which would go alongside Iceberg?
So I think it was that Iceberg is primarily just a library. It's a inactive layer.
Right.
And it's sort of this choke point where you want everything to use the same format. You don't want to have multiple formats, which was actually the thesis behind the acquisition. So you want everyone to have the same thing at that layer. Which means you can't really commercialize that layer. You can't have differentiating features at that layer. It doesn't make any sense. And at the same time, you need a lot of infrastructure on the side. So we decided to be that infrastructure company, building the things that help you take advantage of this, building the APIs that you use to plug in, and sort of facilitating the ability to use Snowflake and Databricks with the exact same data set in one place.
And did the product hypothesis, that was the early hypothesis, like how did that evolve over time as you built the product and as you spoke to more enterprise customers?
Well, first of all, I think the first pivot was just into security.
Yeah.
It was, no one wanted to trust a startup with all of their analytic data. So we very quickly needed to build security controls and really build out the enterprise features of the platform. And then that sort of snowballs into, well, you're an enterprise company now.
Makes sense. Jordan, you've successfully transformed Dremel to BigQuery, serverless, cloud-first BigQuery. There's an opportunity to do that, the same thing, similar playbook. Different from the point of view that was internal to Google. This is external. This is for the rest of the world. And to a certain extent, that's for Google's end users, and you're building MotherDuck for the rest of the world. How do you see that playbook is similar or different for you as you're building the commercial offering on top of DuckDB?
I mean, I think ever since there's been open source, there's been a tension about like, okay, well, how do we build something robust, open source, make it available for the community, be true to open source. At the same time, you want to actually build a business out of it. We heard from Databricks, which is also has had their own version of that and how they do it. And I think a great way of a great model is where you have a robust open source, and then you basically people pay you to run it in the cloud because people understand that, hey, if I'm running these servers in the cloud, there's a cost associated with that. There's a value associated with that. So I do think that the sort of the SaaS model for an open source company is a nice one. But I think one of the other interesting things is that so many open source founders, what they do is they just say, hey, the way I'm going to make money is SaaS. And so they focus on the open source project and making it as robust as possible and as great as possible. And then it's an afterthought to put it in the cloud. And then their SaaS service is, I will just run it in a Kubernetes container and and put an API on it, and then people can hit that API. I think the problem about that is it sort of undersells what is possible with how to actually design a system like to make it work really well. What are things that are only possible in the cloud? Like all their innovation tokens get spent on the open source project. And with MotherDuck and DuckDB, I think we have this really interesting split where the DuckDB team is intact. They have their own company where you basically can pay them for support of DuckDB. And we fund a lot of that support. We also gave them a co-founder share of the company when we started, so they're economically incentivized for us to be successful. We work super tightly with them, and they get to be sort of this sort of clean, community open source company. They don't have to worry about the polluting impact, of venture capital flooding in. On the other hand, we get to focus on making it a business, and then to focus on spending our innovation tokens on building an architecture that really works well in the cloud and kind of pushing what is a cloud database. And I love to like wax poetic about like how we built this hybrid system, and I won't bore you with those details, but I think we think there's a lot of opportunities once you kind of really focus on what is possible in the cloud.
It's also an interesting example of, could be a poster child for that model going forward, because historically, like the same creators have gone out to create companies, and I think you're kind of managing the commercial side of things, and you still have the R&D lab, which is separate from the commercially funded company, which could be an interesting model for venture going forward.
A poster child or a cautionary tale, depending on how it works out.
I would love to have that situation. Can I be the guy having fun and someone else commercializes it?
Yeah, I mean, that's what's awesome about it. Like, hopefully we can get more people to build software that way.
Switching gears a bit, I'd love to talk a bit about like the emerging data trends. And there were like two tailwinds that kind of emerged by looking at Tabular and MotherDuck. I think Iceberg's tailwind kind of points towards kind of unbundling of the data stack, which is people don't want to be like have their data stuck with one vendor. They want like more control over their data. It leads to lower cost, lower complexity, and all of that. And that's leading to kind of a new stack that's emerging. Not that like companies like Snowflake, Databricks, and all of them would be there. But I think the question is like this emerging stack kind of begs new tools. I'm curious, like when you started Tabular, Was this a tailwind that you'd seen at that point from the vantage point of Netflix, or was it more clear when Iceberg became the de facto standard going forward, and how did your worldview change? We'd be curious to hear, do you firstly believe in this tailwind?
Well, I didn't see any of this coming because we really just built for the situation that we had, which was multiple engines interacting with the same table in object storage. And object storage was a lot worse at the time, and forced us to essentially solve the problems that we could sort of work around in the Hadoop days. And that was really an engineering decision, and that's what drove us to start the company, right? So we didn't see any of this shift. It was a big shock to us when data warehouse companies like Snowflake started building support for Iceberg, and we're like, wait, what's going on here? And then we realized that there was that sort of the promise of data warehousing was always bring your data together, you'll get more value out of it. And the flip side of that was the company providing your data warehouse got to charge a premium on compute because all of your data was in the system that they controlled. And so it was a pretty big shock to realize that what we'd built breaks that, and that breaks that dynamic and allows you to put data somewhere and then choose the right tool or who gets to access it, and sort of where your data sits doesn't drive the usage of your compute, which is, I think just very, very disruptive to the warehouse industry.
So assuming now you think is it like a known market trend? Do you believe in the trend? Do you believe that that's going to have its own ecosystem of tools? How do you see that trend evolving?
Yeah, I don't think it's like a huge trend, because I think there are still very few components that interact with this layer. So your warehouse product will be more interchangeable, but there's still a lot driving you to a single product. And I think that it's more for startups, and it enables them. So things like a graph database no longer needs to solve challenges of storage, and I mentioned access controls and governance. Right, you can have a single layer, and so you can get a graph database company that comes in and is really good at what they do without having to worry about all the compliance issues or other things. So I think it's really for how we architect this is going to change, but I don't know that it's going to have ripples that far out.
Jordan, what are your thoughts on this? Given
I definitely have a vested interest in this. MotherDuck, we're building a data warehouse product, and I think if sort of these open data formats, Iceberg, they kind of get taken to their furthest extreme, then it does actually sort of commoditize what we're building. To some extent, that actually could be good for us. If Snowflake is the incumbent, if you're the challenger. Something that commoditizes it, and especially since we can do things for a lot lower cost, and we're not stuck to on huge margins, that can be good for us. On the other hand, I think that there's an assumption in sort of some of the memes around open data formats that that you get it for free. Because there is a lot of value in sort of a tight coupling of how your data is stored and how your data is processed. And I think a lot of people are thinking, yeah, Iceberg sounds great. I want to move everything to Iceberg. And then they sort of they get a little bit down the path, and they're like, oh wait, performance is going to suffer. Oh wait, some of these types of access controls are a little harder to do, or impossible, or fast updates are a little bit harder, and I'm sure Ryan is like, oh, we have fixes for all that stuff that'll be coming. But I think just from an architectural perspective, it's hard to push that past a certain point if you try to enforce this sort of clean coupling of these layers of the system.
Yeah, I agree with you. And what we're seeing right now is actually a restructuring of how you build these things. So yeah, access controls used to be at the top. Query comes in, you check the accesses before you even optimize, probably. so you can fail early. And now we need to get all the way to the data layer because you're protecting tables. And like, how do you even do that? We're still figuring it out. Like I have discussions with cloud vendors and other databases about how we're going to exchange access control information. So it really changes the problem, and we'll see how far it can actually go.
To that point, like we've seen companies like Snowflake and Databricks like be the de facto interactive compute layers. You put in the query, you wait for some time, get the results, and you can do it again and again. But like a lot of companies that need to look at operational data, they are creating their own workflows, pipelines around Spark that give them this incremental compute, so that they don't have to like go back to these full stack platforms to kind of do the interactive piece of compute again. I'm curious do you see like any kind of opportunity on that side for anyone to own incremental compute pipelines because a lot of companies are kind of building those using Airflow, Spark, and so on internally. And a lot of that data is in databases, is in your S3, is in Kafka. It's not being thrown into the warehouse. So I'm curious, like, do you see that aspect of unbundling happen at all?
There's certainly, like, everyone needs to build. You can't just recompute everything all the time.
Yeah.
Netflix had, I think, 5 different schedulers and ways of doing this when I was there.
Yeah.
So this is not a well-solved problem.
Mm-hmm.
Certainly, once you look at like the challenges of like streaming in this space, I think that we are seeing more and more maturation in especially the streaming area. So things like table flow and being able to back a stream with something more permanent, so you don't have only a 4-hour window to fix problems before you start losing data. Mm-hmm. Those sorts of things absolutely need to happen. So maybe as things mature, but yeah, I think that's also a little higher than I normally sit in the stack. What do you think?
Yeah, I mean, I think for a long time, streaming seems to have been just around the corner as soon as we can get the right ways of wrapping up streaming. And I think one of the problems is people's brains just work in big batches. And you can, narrow the batches and do, a bunch of little incremental things. But, I think I wish everybody was comfortable processing data in streams. Like, streaming systems are so much more elegant, and you don't have these cases. Like, you can find problems like immediately when they happen, rather than like having to worry about this schedule of when things run, and like you have to fix it by the next one. And like, there's just so many things in the world that get better in a streaming situation. But I don't know. We'll see if we can get the right tooling. Every once in a while, a new streaming company will come out, and you kind of hope, hey, this is going to be the one. And I'm not sure we're quite there yet.
You touched on an interesting point around looking at like narrow data sets, and I think it goes back to the next trend that MotherDuck and DuckDB is leaning in, which is small data. You had a huge conference, small data conference recently. And I'm wondering what makes you lean into that worldview more, given your background at BigQuery, which is obviously big data, and how does that change based on like what you're seeing in the market today?
Yeah, I was actually talking to the guy who was the site director of the Google Seattle, which is actually where BigQuery was started, Google Cloud Dataflow was started, Compute Engine was started. Cloud storage was started. So a lot of Google's cloud he's sort of responsible for. And I was talking about like this idea, and I mentioned that like in BigQuery, most people did not have big data. Like most queries were sub 100 megabytes, which is tiny. Most people didn't have a lot of data. And he's like, well, why would you use BigQuery if you didn't have big data? And it turns out there was a different problem that we were solving. We were actually solving 2 problems. One is big. How do you go big? But a very narrow slice of the population had that problem. it was mostly actually, it was easy. It was BigQuery and Easy Query, and they kind of wrapped it up in one thing. And so we're like, well, what we're doing actually is we're building Easy Query. In fact, that's what like an internal code name for what we were doing at MotherDuck was called for a while. And one of the things that actually pushed me into the direction of starting MotherDuck was I don't know if people remembered the Databricks and Snowflake had this big spat. Like they did these benchmarks and it's like, we're faster. No, we're faster and we're faster. And it was kind of sordid and hilarious for people on the sidelines. But to me, the shocking thing was that the data size that they were using was 100 terabytes. And that's massive. Like literally nobody in BigQuery was using data that big. And we had some of the largest customers in the world. We had Equifax, HSBC, Walmart, Home Depot. And it's like, okay, well, these are the biggest companies in the world that are the market leaders. They believe that like kind of what's important is to fight at this data size versus like 100 gigabytes, which is 1,000 times smaller, which I think is much more interesting and much more where the sweet spot that people have. And it's like, hey, there's an opportunity there to go after like the size data that people actually have, make it easy. And then when you simplify, when you go after that size, you can simplify things so much, and you can move faster, and you can kind of do things in a different way. Instead of like having to centralize all the compute, because that's where the data is, you can actually move the data and the compute out to like closer to where the users are, and you can make it faster, and you can make it work better, and you can do all these sort of other interesting things. And that's sort of how we got onto this sort of like small data trend is just sort of the recognition. And even when I was at Single Store, like we had an instance that was a quarter of the size of the smallest Snowflake instance, and people are like, yeah, can you do one that's even smaller? And it's like there was this real hunger for like being able to handle smaller data sets or normal sized data sets in a more effective way.
And it's interesting that the last couple of years, the entire view of the so-called modern data stack, no one likes to use that jargon anymore, but like all the tooling that's been built out, whether it's Fivetrans of the world and the warehouse, the Lookers of the world, all of them have kind of had this narrative of like big data. I'm wondering if like small data is what people use, like why can't they use the same tooling that's already been built out? Why does it require like net new tooling? Is it mostly like technical debt, technical tax that they need to pay, or like what is your view on that?
I think it's a lot of us around just like ease of use. Mm-hmm. And like one of the interesting things about DuckDB is they have like a full-time like PhD level student or engineer working on the CSV parser. The CSV parser in BigQuery, taking this sort of the dumbest possible data format and getting it into the database was something that we had like a new hire work on in BigQuery for like 3 months. They shipped it and we're like, okay, that's done. But so many people actually building data tools or working with data, they're like, oh, I've got this silly CSV file and it's got this like weird quotes in the middle and like it has all these, and like they spend all of their time working on how to get that damn CSV file in versus like actually trying to answer questions about the data. And I think you can, if you kind of focus on those problems rather than like scale, then you can actually make things better for users.
Ryan, you worked in the world of big data and scale data at Netflix and Cloudera. What are your thoughts on?
I completely agree. I think what matters is usability. Yeah. It comes down to how easy is it to use this thing. I think a lot of the time we focus on like, hey, can I use the same tool for an analyst over here and the biggest problem at my company? And that's somewhat why we care about big data. Mm-hmm. It's also great for getting in fights with other companies, right? But it really does come down to usability. One of the reasons why Apache Iceberg took off as a project was that we didn't just make these large data sets something you can share across engines. We said like, oh, we actually want to restore the SQL table abstraction, so people don't have to care about what's underneath that level. We said like, it's ridiculous that we're creating a new data something title every 3 years because like we have just challenges that we're throwing on people that they shouldn't have to do, right? Data engineering is basically like, hey, we didn't build the database right, so you guys handle it. And we literally had people that were, using a scheduler to determine when they're going to compact their tables, and then saying, no one read the table after 11 o'clock at night. Like that's just the wrong way of building a database. And I think like this focus on big data is, for at least other companies, probably a symptom of the same problem. I care mostly about like how simple is this to use, and at the margin, it's like, well, can I get larger than what I can run on my laptop? Do I have to not download things? Like, I think we don't want people focusing on like, hey, I want small data too. We'd want them to stop caring about size.
Assuming simplicity.
Yeah, just if I could add one thing.
Sorry.
At Google, we used to say like, we don't talk about big data, we just talk about data. And I think that's like the world that we should live in. We just sort of talk about data and what you can do with it.
Yeah.
Assuming simplicity is kind of the cornerstone and the forefront, which matters right now. Assuming that like we still have talked about like two trends, let's move you into prediction mode in terms of like, if you look at the stack today, if you look at the end user pain points today, where do you see the opportunity going forward? Either in terms of like an emerging trend or in terms of like a new primitive, that bringing it back to the topic of the discussion that you think needs to exist, that'll make people's lives easier.
Well, so I think of the trend being more towards shared infrastructure, and how do we separate the compute layer from the storage layer. Mm-hmm. And the biggest trend there, I think, is catalogs. So how do we have one central catalog that manages and knows about all your data and provides access controls, and then on the simplicity side, allows you to really easily plug in a new product, right? Can I plug in a new streaming service that works with my existing table infrastructure using just OAuth, the same sort of thing that you would use to give Facebook all your contacts, right? I think that is how easy it should be for an administrator.
And how do you see, I'm assuming one part of answer it might be usability, but how do you see that cataloging primitive to be different than the enterprise catalogs that we have today?
Well, so catalogs need to be low level and high level at the same time. And I think we actually conflate them quite often. It'll be interesting to see what happens over the next few years. But what we were building at Tabular is sort of this catalog layer that was Iceberg specific. And then, of course, you need views. And then, of course, you need Hive tables and like older things. And it grows. But at the top of the stack, it's not doing the same thing. It's not actually tracking the like technical metadata of how do I make this thing a table. It's more the business logic and things like that. I'm not sure that those are going to be one category or two categories in the long term. I think it depends on what gets built. But there's just a ton of movement in that space right now.
Makes sense. Jordan, I know we are out of time, but the mic is yours.
Yeah, I think catalogs is a super interesting area that like I feel like I have no idea how any of that's going to shake out, and I feel like Ryan is one of the world's experts on that, and so I'm hoping that the world ends up in a sane place. My one prognostication would be that I think more stuff is going to happen locally. I think especially if you're not dealing with giant amounts of data, you can run it on your laptop. You can push things down to your laptop. If you're dealing with AI models, like smaller models, things you can run on your laptop, things you can run on your cell phone, are going to start to become a lot more powerful, and people are going to be able to do a lot more things in a disconnected way.
Great, Ryan, Jordan, thank you so much. Really grateful to have you here.
Thanks for having us.